This video, we will solve problems from exercise 1.3. Question number 14. The distance of an object falling is a function of time t and can be expressed as s of t is equal to minus 16 t squared. Graph the function and determine if it is 1 to 1. So what's given to us is a function s of t is equal to minus 16 t squared, where s of t is the distance and t is time. We all know the time has to be a positive number, so we will start considering positive numbers for t. Let's look at this table here. Let this be the t value, not t1, and let this be s of t. So let's first take our t to be 0. So when t is equal to 0, s of t is equal to 0. When t is equal to 1, your s of t will be equal to minus 16 into 1 squared, which is minus 16. So this is 0 here, 1 minus 16, and if t is equal to 2, your s of t is equal to minus 16 into 2 squared, that is equal to 64. So this is minus 64. So minus 64. When t is equal to 3, your s of t is going to be equal to minus 16 into 3 squared, that is minus 144. So 3 will be minus 144. So let's start to plot these points. So let's call this as 1, 2, 3 in the x-axis, which is t, and let's call this as s of t, and let's plot. Let's take 10, minus 10, minus 20, minus 30, minus 40, minus 50, minus 60. So just from these values we can plot. It's 0, 0 here, that's 1. Okay, you can put an x. Then when it's 1, it's minus 16, so it's somewhere here. And when it's 2, it's minus 64. It's somewhere here. So then the other point is going to be somewhere all the way down. So if you connect these points, you will get a parabola. But since t is not negative, I will just put the dotted lines just to show if it is a negative value. But we're going to take only the positive values. So in this parabola, you will see that it's a 1-to-1 relation, because every value of t has a unique value in s of t, which means when t is equal to 0, it has a unique value 0. 0 doesn't take any other or pre-image on t. And 1 will be minus 16, 2 will be minus 64. So each value of t will have a unique value in s of t. Therefore, every element in the domain set t has an unique value in the range set s of t. Therefore, it is a 1-to-1 function. Question number 15. The total cost of airfare on a given route is comprised of the base cost C and the fuel surcharge S in rupees. Both C and S are functions in the mileage M. C of M is equal to 0.4 M plus 50 and S of M is equal to 0.03 M. Determine a function for the total cost of the ticket in terms of mileage and find the fare. for flying 1600 miles. So what is given to us? So given C is equal to base cost and S is equal to fuel surcharge, and M is the mileage. And also given to us is C of M, the function base cost in miles is given as 0.4 M plus 50, and S of M is equal to 0.03 M, right? So the total cost is equal to C of M plus S of M. C of M plus S of M. Right. So what is C of M? C of M is 0.4 M plus 50 plus S of M is 0.03 M. So that's nothing but 0.43 M plus 50. So this is the total cost. Now, to find the cost or the total cost of a ticket in terms of mileage, we will use the function total cost is equal to 0.43 M plus 50. Now to find the airfare for flying 1600 miles. So airfare for flying 1600 miles will be equal to, we have already calculated the total cost in this function, so let's use that. 0.43 into ms 1600 plus 50. So simplifying this, you will get 688 plus 50, that's equal to rupees 738. Question number 16. A salesperson whose annual earnings can be represented by the function a of x is equal to 30,000 plus 0.04x, where x is the rupee value of the merchandise he sells. His son is also in sales and his earnings are represented by the function s of x is equal to 25,000 plus 0.05x. Find a plus sx and determine the total family income if they sell rupees 1,500 worth of merchandise. All right, so what's given to us is first the father's income in terms of the function a of x is equal to 30,000 plus 0.04x, and the son's earnings in the function s of x is equal to 25,000 plus 0.05x, where x is the rupee value of the merchandise he sells. Right. So now to find a plus s of x. So this can be defined as a of x plus s of x. So if we substitute these values, 30,000 plus 0.04x plus 25,000 plus 0.05x. So that's equal to 55,000 plus 0.09x. So this is the, let's call this as the total income of the father and the son. Now what is given is that they each sell rupees 1 crore 50 lakh worth of merchandise. Okay, so each sell rupees 1 crore 50 lakh worth of merchandise. Okay, so our x is common for both of them because the value of the x is the same. So therefore, the total family income will be equal to 55,000 plus 0.09 into 1 crore 50 lakh in terms of rupees. So this is into here. So doing this, 55,000 plus 13 lakh 50,000, and that is equal to rupees 14 lakh and 5,000. Question number 17. The function for exchanging American dollars for Singapore dollars on a given day is f of x is equal to 1.23x, where x represents the number of American dollars. On the same day, the function for exchanging Singapore dollar to Indian rupees is g of y is equal to 50.50 y, where y represents the number of Singaporean dollars. Write a function which will give the exchange rate for American dollars in terms of Indian rupees. Okay, so what is given to us is American dollar. So f of x, this is equal to the Singaporean dollars. Okay, is equal to 1.23x, where x is American dollar, US dollar. Similarly, what you're also given is Indian rupees. I'll call it as INR, is equal to g of y, which is equal to 50.50y, where y is Singaporean dollar. So what we have is, when you're given the US dollar, right, and you convert it to Singaporean dollar using the function f of x, where US dollar indicates x. So if this is Singaporean dollar is y, then you convert it to INR using the function g of y. All right, so that's, you can see it's like a composite function. Now what is asked is, write the function which will give you the exchange rate of American dollars in terms of Indian rupees. So now we are given this US dollar, you need to get INR. So it's a composite function. So what we need to do is g of f of x. This will give you the conversion from US dollar to Indian national rupees. Okay, so let's expand this. So g of f of x is equal to g of, your f of x is given by 1.23 1.23x. So that's equal to, and g of y is 50.50 into 1.23x. So that is equal to 62.115x. So that's your conversion rate. Question number 18. The owner of a small restaurant can prepare a particular meal at a cost of rupees 100. He estimates that if the menu price of the meal is X rupees, then the number of customers who will order that meal at that price in an evening is given by the function d of x is equal to 200 minus x. Express is daily revenue, total cost and profit of the meal as a function of x. So what's given to us is cost per meal is equal to rupees 100, and therefore the total cost would be equal to, because your demand function is d of x is equal to 200 minus x, so he would have had 200 minus x number of meals into 100, where x is the price of one meal. Please note, when I say cost, this is cost of his production, and this price is his selling price. X is the selling price, and d of x, which is equal to 200 minus x, is the number of customers, right? So we have the total cost of manufacturing, the meal per day, and cost per meal is rupees 100. Now, his day revenue is equal to, how many meals does he sell? 200 minus x, and he's pricing each meal at x rupees. So this is his daily revenue in rupees, and even this is in rupees. And also the total profit is equal to the day revenue minus the total cost of preparation. Okay, so which is equal to, your day revenue is 200 minus x into x minus the cost of preparation is 200 minus x into 100. So you can simplify this as, since 200 minus x is common to both, 200 minus x into x minus 100 rupees.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.